When we are looking at the domains of our functions, right now at this point, it's gonna change when we get to doing other types of functions, is we have to make sure that our values that we put into our functions, our inputs, are real numbers when I have outputs. My inputs are going to be real numbers, but I also have to make sure what comes out is a real number. So at this point, we look for when we have x in the denominator. When x is in the denominator, we ask ourselves, is there a value in which I can choose to put in for my denominator x that's going to make this undefined or a non-real number? And the way I determine that is I say x plus 3. I have to ensure that the denominator equals 0. If it factors, I factor. If it doesn't factor, then I can go ahead and just solve for x. And so x cannot equal -3. If x was -3 for my f function, then I would have division by 0, and with the division by 0, we know that's undefined. So by my domain for f, d, and I'm just going to subscript it f, so we know we're talking about the domain of f. If I do it in set builder notation, it is x such that x does not equal -3. If I write it in set builder notation, I get anything to the left of -3, so negative infinity to -3, and that parentheses tells me I don't get to include -3. So I'm going to come from the left, I'm going to get really close to -3, but I'm not going to include it. And then my u means that I'm going to walk over or step over that -3. And then I'm going to keep going on the right side of -3. So that is the domain for my f function. For my g function, let me just erase this. For my g function, I look to see the other issue that I have is when I have x underneath a square root, a fourth root, a sixth root. So anytime my index here is even, then I have to make sure that whatever's underneath that square root, in this case 3 minus 2x, has to be at least 0. So it has to be greater than or equal to 0. So then what I do is I just solve, and so I'm going to add or subtract 3 from both sides. So -2x is greater than -3. When I divide by a -2, then I'm going to have x is less than or equal to. When I divide by a negative number, my inequality changes direction. So don't forget that. So when I divide by a negative number, my inequality changes direction, and so I end up with 3/2. If I write this in subscripted g, d of g, domain of g, if I write it in interval notation, I have x such that x is less than or equal to 3/2. And then if I write it in set builder, so that's set builder notation, if I write it in interval notation, then it's going to be everything that's on the left side of 3/2 and including. So negative infinity is on the left side, up to 3/2 inclusive, and my infinities, of course, are never inclusive. Does anyone have any questions on that? Again, you can unmute yourself, or you can write it in the chat if you have any questions. Okay. So if there's no questions, then we're going to go ahead and do this evaluation. And if we're asked to evaluate for a piecewise function, I have to determine which piece that 8 goes into. I have 3 pieces. I have my first piece, I have my second piece, and I have my third piece. Now I'm trying to figure out which piece, because that 8 will not go into all of the pieces. The piece in which that 8 will go into is the last piece, because that is the one in which 8 is greater than 2. So that's where I put that. So I'm asked to evaluate f of 8. Then I use my last piece, which is 8 divided by 2 minus 1. So 4 minus 1, which is 3. This one is 1.5. So I have to figure out where that lands. It is not left of 0. It is not larger than 2. And so that f of 1.5 is going to go into the second piece. So f of 1.5 is equal to negative 3 plus 1.5 squared. I'm going to get my calculator out. I'm going to do 1.5 squared. And I'm going to make sure that I add to it or subtract off 3. And so my final answer is negative 0.75. Now for my last piece, or my last one, this negative 4 is left of 0. So if I'm asked to evaluate f of negative 4, then this is just going to simply be negative 3. So no matter what happens on the left of 0 and up into including 0, no matter what I have, then the answer is always going to be 3, negative 3. It's just a horizontal line at y equals negative 3. So let's take a look at 3. I'm going to give you a minute or two to do 3. So if you all could do number 3, please. All right, does anyone have an answer for A, h of 2? You can type it in the chat box. You can unmute yourself. You can raise your hand. Is anyone? Okay, so 0. Do you have confirmation? Yep, I have confirmation on that. Perfect. What about h of negative 2? We got 4. Do we have confirmation on that? Yeah, we have a couple of confirmations on that. What about h of x plus 3? How do we do h of x plus 3? So when we are looking at h of x plus 3, what we are asked to do is, just like when we evaluated at 2 and negative 2, is we are asked to put in wherever we see x, we're going to replace x with x plus 3. Now I think we actually did these last week. We're going to go over them again. And so what I have for x plus 3, the quantity squared, this is x plus 3 multiplied by x plus 3. So don't forget that when I see x plus 3, the quantity squared, it is x squared. Or it's x plus 3, the quantity squared. It is x plus 3 multiplied by x plus 3. So when you multiply that out, you're going to get x squared plus 6x minus 9. And don't forget to distribute that negative through, so it's negative x minus 3 minus 2. So what I did was I took this negative 1 and I distributed it through. And now, combining up like terms, I get x squared. I have a 6x minus x, so that gives me a 5x. And then I have negative 9 minus 3, which is negative 12, minus 2 more, which is negative 14. Oh, that should be a positive 9. Helps if I pay attention. Sorry, that should be a positive 9. So it is 9 minus 3 is 6, minus 2 more is positive 4. And that should be my final answer. How was 3? What kind of questions do you have for me on number 3? Because I've got a wide range of answers. What kind of questions do you have for me on number 3? So what we did on 3C was we actually did a composition of functions. We took one value, not numeric, and put it into, and we took one expression, which is not numeric, into another equation or another function, and that's what we're doing today. Is we are doing what we call compositions of functions. So first, before we do the compositions of functions, we're going to learn that we are going to do addition and subtraction and division and multiplication of functions. And we're going to talk about the domains as we do it. So that's why we started out with a warm-up of number 1 and number 3, is to get ourselves like, oh, I know how to do compositions of functions. It truly isn't anything new. We did it on 3C, which is what we did when we first started learning functions. We actually did number 3 last week. And then number one, we've been talking about domains for a while. So what we're doing is kind of bringing some of the stuff we've done before as pieces into a bigger idea. So the first thing is we're going to talk about what it means to add and subtract functions. So the notationally, when I see x plus f plus g of x, that just means, notationally, that just means I'm going to add my two functions. So if I see f plus g of x, so f plus g in parentheses, x on the outside, what that's just telling me is it's a shorthand notation of take my f function, add to it my g function. And then if I see x or f minus g of x, same kind of thing. It says take my f function, subtract off my g function, and don't forget to distribute the negative. If I see fg of x, that just means I'm going to multiply the two. I'm going to take my f function, I'm going to multiply it by my g function, and I get a multiplication. And if I see f divided by g of x, then I'm asked to just divide the two. And that's, of course, provided, that my g function, whoever I'm dividing by, that's this last one right here, whatever I'm dividing by does not make that undefined because I'm dividing by 0. So if I'm asked to add the function or subtract the function or multiply the function or divide the function, I just got to make sure as I'm doing this that I just keep the order of making sure I multiply, subtract, add, or divide. So I'm not going to do these. I'm going to have you do these. So I'm going to choose two other functions in which I'm going to do the addition and subtractions. So the two functions that I'm going to choose is I'm going to say I'm going to let g of x equal x squared plus 1. I'm going to let f of x equal x minus 3. So if I was asked to add these two, then mine, and you all are going to do those functions, x plus 2 and x squared plus 5x plus 6. If I were asked to add these, then for mine, I'm going to do this in green. This is just going to simply be x minus 3 added x squared plus 1. Now, when I'm asked to add these two, you can see that I didn't actually need to put these in parentheses because I don't have to worry about distributing a negative, but I did put the parentheses there anyways. And so if I'm asked to just do the addition here, then I'm just going to add them and making sure that I add up like terms. The only like terms I have is the 3 and the 1, so this is going to be equal to x squared plus x and then minus 2. For the subtraction, I'm going to make sure that I pay attention to who's being subtracted from who. And so my f function is first, x minus 3. And I'm going to subtract off my g function, which is x squared plus 1. So my first grouping, I really didn't even need the parentheses, but the second grouping I did to make sure that I remembered to distribute the negative through. So this is going to be equal to x minus 3 minus x squared minus 1. And then by cleaning this up, I'm just going to write my x squared first and combine them up like terms. So negative x squared plus x minus 4. And then on my multiplication, then I would just multiply x minus 3, x squared plus 1. And I distribute, making sure that I distribute. And when I distribute, I'm going to get x to the third. And then I'm going to have plus x minus 3x squared minus 3. And then just reordering it so that my powers are in descending order, I get x cubed minus 3x squared plus x minus 3. And then for my division, I got to pay attention to who's dividing who. And so for my f function, I have my f function is x minus 3 divided by x squared plus 1. And then the other way is asking for my g in the numerator, so that's x squared plus 1 divided by x minus 3. And then my last one is to go ahead and put negative 2 into what I just did. So this last one is just asking me to put negative 2 in there. So I have negative 2 squared plus 1 over negative 2 minus 3. So I have 4 plus 1 over negative 5. So I have 5 over negative 5, so my answer is negative 1. Now, is there any questions on that before you all do yours? You're going to do x plus 2, and you're going to do x squared plus 5x plus 6 as the two in which we're going to add, subtract, multiply, divide both ways, and then do the evaluation. Do you have any questions before I have you do these yourself? All right, so I'm going to go ahead and pause the recording, so this give you a chance to do the work yourself. So if I'm asked to add them, then I go ahead and just combine up like terms. So I have x squared plus 6x plus 8. Looks like we're all in agreement there. What about the subtraction? Is anyone willing to unmute themselves or write the answer in for B? Okay, so with B, you got to make sure that you pay attention to your negative signs. It looks like we've got some agreement here. And so we've got x plus 2, and then it's minus this entire quantity, x squared plus 5x plus 6, which means we have x plus 2 minus x squared minus 5x minus 6. Writing it in descending order and combining up like terms, I get negative x squared minus 4x minus 4. Looks like we have agreement there. What about the multiplication? It's kind of a bear, but it's not too bad. Anyone willing to give me their, yep, okay, so we've got some multiplication, and looks like we have an agreement on most of it. I think one forgot just to type the power on it, but it's hard to type these with the power, but it looks like the agreement is x cubed when we multiply it through, plus 7x squared, plus 16x plus 12. And the way that you find that is you're going to take your x plus 2 and you're going to distribute it onto the x squared plus 5x plus 6. And in this case, you're going to have to distribute the x onto 3 terms, and you have to distribute the 2 onto 3 terms. And then you're going to combine up like terms, and it looks like we have agreement on that one. What about the division? F divided by G. F divided by G. Awesome. So we for D, we do get some simplification, and that's going to lead us to E as well. Is if I look at F, or excuse me, D, it is x plus 2. Go back to my blue. It is x plus 2 over x squared plus 5x plus 6. And the denominator does factor, and so I get x plus 2, and then the denominator factors into x plus 2 and x plus 3. Now, what will happen is that the x plus 2's will cancel, leaving me 1 over x plus 3. If I'm asked to do the division the other way, then it's just going to be the reciprocal of this answer. So I just end up with x plus 3 over 1, or just x plus 3. When I'm asked to do the F, on F, I'm asked to do G divided by F of negative 2. What did you all get for this one right here? What did you all get for that answer? Okay, so hopefully we got some zeros. We got some zeros with question marks. We get 0 over 0. Courtney, you are a rock star. 0 over 0 is what you end up with because you're dividing by 0. So what I had over here is I had before the reduction, I had x plus 2, x plus 3 over x plus 2. Now, that goes back up to here. We get to do that division provided g of x does not equal to 0. G of x cannot equal 0 because what ends up happening, if I were to put in right here a negative 2, then I would have been trying to divide by 0. So I did put that in there because it's really easy to forget that we have to make sure that I have to pay attention to my domain. And my domain is, each individual domain, the f and the g function, the domains are everything. But the moment I start to do divisions, I have to pay attention to make sure that I'm not trying to evaluate something that is not part of the domain when I do a division. So when I have 0 divided by 0, this doesn't equal 1 because I can't divide by 0. It doesn't matter what's in the numerator. I'm not allowed to divide by 0. And so what I have for this one is undefined. So I can't actually put -2 in there, even though my simplified version is just x plus 3. But because I couldn't have -2 to begin with before I simplified it, then f is actually undefined, and that's because of this rule right here. It says, hey, I get to do this division, provided of course my function is not equal to that. So the answer to E is x plus 3, provided of course I don't get to evaluate it at x equals -2. So for F, my answer is undefined. And then this is the answer to D. So how was that? Yeah, so it is interesting. And like I said, I want you to see the math here when it's clean and fresh and not out on the streets. So we've got to talk about the more difficult questions, the more, quote, tricky ones, because I need you to be able to do the homework without a huge amount of issues. Now we're going to talk about what happens when we have to include the domain. Now this one, up until we did the divisions, we really didn't have to worry too much about the domains because they were both all real numbers. For this example, I have to pay attention to the domains. I'm asked to do the same thing as I'm asked to do their divisions, I'm asked to do the multiplications and the additions and the subtractions. But before I even do that, I have to pay attention to the domains because I got to make sure that when I do the additions, subtractions, multiplication, divisions, both ways, that I don't do what I did with F and try to put in something that should have been undefined. So the first thing I do, if I'm asked to find the addition, subtractions, the algebra of the functions, and I'm also asked to find their domains, then I find the domains of each function individually first and see whether or not anything changes as I do the algebra of functions. So is there any problems on the domain? I'm going to start with this one first. Is there any problems with finding the absolute value of any real number? Is that one of the two things I look for? The answer is no. I am looking for square roots. I'm looking for x's in the denominator. So the domain of G is everything. So I can put anything I want in for G. Do I have any restrictions on my F function? Do I have some issues here? So on my F function, because I see the square root, it tells me I'm going to have problems. So I set that whatever's underneath this square root, right here, greater than or equal to 0 and solve. So go ahead and do that and tell me what the domain is in interval notation, please. Type that in the chat or unmute yourself. The interval notation for the domain of F, please. So the domain of F. When I'm trying to find the domain when I have a square root, I'm going to set whatever is underneath this square root to be greater than or equal to 0. It can equal 0. I can do the square root of 0. That's totally fine. Square root of 0 is just 0 all day long. So with that in mind, then what I do is, because I have the square root of 0 is fine, I can put that in my calculator. It gives me 0 out. Then I'm just going to subtract 2 from both sides. So negative x is greater than or equal to -2. And x is less than or equal to, change in the sign, 2. So in interval notation, I have from -infinity to 2, and I do get to include 2, because you all get your calculators out, and if you did the square root of 2, or square root of 0, square root of 0 is okay. The square root of -1 is not okay, but the square root of 0 is okay. So that's why the domain of that one is from -infinity to 2. Now, I'm asking you to do the algebra of this. So if I were asking you to do the f plus g of x, then I'm asking you to just add these two functions. So the square root of 2 minus x plus the absolute value of x, and that's as good as it gets. I can't do any additions or subtractions because I have no like terms. I can't square both sides because I'm not solving an equation. All I'm doing is adding two functions. So I don't get to square anything. I don't get to take absolute values off. The best I can do is just add them. Now the reason I chose these two is really to focus more on the domain itself than on the algebra of adding and subtracting like terms. So for this particular function, what I have is I have the absolute value of x, no issues, but this part of this addition of this new function, this part says that it's going to dominate. That's the part I care about. It's going to dominate everything else. So the domain for f plus g is going to be the dominant one domain. Because I can put anything into the square root, or absolute value. The same thing is going to be true when I do the subtraction. The only thing that changes here is that I'm going to have minus the absolute value of x. Still don't get to add anything. Still don't get to subtract anything. So its domain is going to be the same thing. So this is the domain of f minus g. If I were asked to find the multiplication, the best it gets to be is 2 minus x times the absolute value of x. And again, what's going to dominate is this. So those two are still, that square root of x, 2 minus x is still dominating. So this is also going to be equal to the domain of the multiplication. It is the moment we get into division that we start caring about changes in what our domain is. So if I'm asked to find f divided by g of x, then my f function is the square root of 2 minus x, and then I have the absolute value of x. Now, not only do I have to worry about the numerator, negative infinity to 2 inclusive, I have to pull out anything here that makes that to 0. So even though the absolute value is totally cool, I can put anything I want into the absolute value, but because it's in the denominator, I can't let x equal 0. So my domain with this division has changed. So the domain of f divided by g is going to go from negative infinity to 0, non-inclusive. I'm going to jump over 0 and go to 2. So that's the domain of that one. Then I'm just going to do the domain of the last one, and then I'm going to pause this and ask what kind of questions you have for me. So g divided by f of x, and this is going to be equal to the absolute value of x over the square root of 2 minus x. Now the absolute value is in the numerator, so we don't care. We can put anything we want it. The denominator is going to dominate because first of all it's a square root and it's in the denominator. And this is where I don't get to include 2, negative 2, because it is in the denominator. And let me see, it should have been negative, no, it's 2. So I don't get to include 2. So the domain for this one of g divided by f is from negative infinity to 2, but this is where I don't get to include 2. Now I'm going to pause this. I'm going to ask you, what kind of questions do you have for me? Okay, so let's take a look at B. So I'm going to first do the domain of f. So the domain of f is everything except for 0. So I'm going to do an interval notation, negative infinity to 0, union between 0 to infinity. Because I can't have 0 in the denominator, it's 1 divided by x, so I can't have 0 in the denominator. And then for my g function, I set whatever is equal underneath the square root greater than or equal to 0. So my domain for my g function is from 5 to infinity. So when I do the addition and subtraction and multiplication, so my addition, f plus g of x, is just going to be 1 over x plus the square root of x minus 5. There's nothing there that I have to worry about doing simplification. I mean, I could make it a single fraction, but I'm just going to leave it like that. In this case, again, the square root is going to dominate. And the reason the square root is going to dominate is because I have to start at 5. Because I have to start at 5 on the domain of G, I don't have to worry about the fact that the domain of F says I can't have 0. Because I can't put 0 into my G function anyways. So my domain of F plus G is going to be 5 to infinity. When I do the subtraction, the only thing that's going to change here is 1 over x minus the square root of x minus 5, and it's also going to have the same domain. When I do the multiplication, it is going to be 1 over x multiplied by the square root of x minus 5, and it also is going to give me the same domain. So this is the domain of the multiplication. In order doesn't matter. So basically what the gist is, once you find the domain of the addition, you'll have the domain of the subtraction, and you'll have the domain of the multiplication. Now we have to worry about the division and see if anything changes. When I'm asked to find the f divided by g of x, so I have 1 over x over the square root of x minus 5. I do have a little bit of simplification on this because I can't leave a complex fraction. So this is going to be 1 over x, the square root of x minus 5. And its domain didn't change, except for when I do this, I can't include 5 because it's in part of the denominator. And that should actually be, let me erase this. This should actually be like this. X minus 5. So my domain, I picked up something new. So the domain of f divided by g is non-inclusive 5 to infinity. And then lastly, when I do g divided by f of x, then this is going to be g, which is the square root of x minus 5 divided by 1 over x. I have to clean this up, and so I get x multiplied by x minus 5. And what I didn't pick up anything new for my domain issue, so my domain for this one of g divided by f is inclusive 5 to infinity, and that's my final answer. Now we're out of time, so when I see you all tomorrow, I'm going to just leave this up for those of you who are still writing. When I see you all tomorrow, we're going to be doing the compositions of functions, and we will be finishing up this section tomorrow. You all have a great day. Remember, I have office hours between 12:30 and 2 today, and if you've already made an appointment to meet with me later today or during I have an appointment window between 10 and 10:50. So if you have already made an appointment with me between 10 and 10:50 today, I will see you then. Otherwise, I'll see you in my office hour. Have a great morning and the rest of today, and thank you for staying a little bit later.